Can everyone hear me?
Yeah.
Thank you. How do you find the first two lectures? Is it easy?
Yeah,
Yes, this link for 3 to 4. Yes. In case everyone didn't notice, I posted the worksheet on Quarkus. If you go to Quarkus and then you scroll down, you will see tutorial material. And then there is the link to the tutorial note for both my sections and John's. And the thing is, for this week, we decide to solve different questions in each tutorial. So I want your opinion on this. Do you want us to solve the same questions for every tutorial, or do you want us to solve different questions? Because I feel like if we solve different questions, maybe you will have more material to study, but I don't know, maybe some students find that it's too many questions for them to go over and they don't like it. So just let me know what you think about that. And then I will change from next week.
Could you repeat that?
For the tutorials and upload the recording after our sessions end. Okay, it's 2:11, so I will start the tutorial. If you have any question while I'm explaining, please let me know in the chat and I will get back to you. The tutorial today, we will talk about the concepts of set. If you took Math 102 before, probably you see it already. And then make sure that you know the definition for subset. We will talk a little bit about the sample space and events and some basic set operation that you will work with. So we will first start with set. Set is just a collection of distinct objects. And you indicate it by the curly bracket like this. And there are two ways for you to express a set. The first one is you can just list out all the elements in the set. For example, like S equal to 2, 4, 6, 8, 10, ... Like this. When you try to list out the element, that is one way to write a set. And the second way is you can use a set builder notation. I will say that this set S include all the element X such that X is a natural number and X is even. Does this part make sense?
Yeah.
Thank you. Shouldn't it be X modulus 2 equal to 0? Yeah, that is the same thing, right? If X modulus 2 equal to 0 is the same way to express X is even, right? There are different ways to say about one concept. As long as you say it correctly, you will get full mark. Okay, next one I want to talk about is the cardinality of a set. The first situation is you have a finite set, which means that the number of objects in the set is a finite number, like is a specific number that you can tell. For example, a set S contains 1, 2, and 3. Then the number of elements in this set is 3. We will say that the cardinality of this set is equal to 3. So for a finite set, the cardinality of a set is just the number of objects that you have in the set. Does this part make sense? Okay. The second part is infinite set. It is when the set has infinitely many elements. It doesn't stop at like 3 elements, 5 elements, 10 elements, or 1,000 elements. Those are the situation of finite set. For this one, you can just keep generating the elements of the set forever. 2, 4, 6, 8, something like this. I have a question. Infinite equal to continuous sets, right? We will get to there. For infinite sets, oh wait, never mind, that's uncountable. Yeah, that's correct. For infinite, there are 2 situations. The first one is a countable set. It's infinite, but it's countable. It sounds really contradicting, but there is such a concept. And the second situation is it is infinite, but it is uncountable. So what is a countable set? A countable set is something like the set of natural number, the set of all evens or odd number, or like the set of rational number. So those are the most common countable infinite set. And there is actually a way, like a formal mathematical way to test whether an infinite set is countable or not, but we will not deep dive into that in this course. For this course, you just need to know common countable but infinite set, like the set of all natural number, the set of all evens and odd number, the set of rational number, and then also the set of integers. And uncountable infinite set is the set of all real number or any intervals that you see, like closed interval, half closed interval, or open interval. So those are the common infinite uncountable set. And for this one, it will relate it to continuous. The thing is, if you think about it, let's say the set of natural number, you have 1, 2, 3, 4, 5, 6. It is countable set, even though it's infinite, because let's say I give you number 2, you are able to tell me what is the next element after number 2. We know that is 3, right? If I give you number 100, you can tell me what is the next element. It is 101. So that's why it's countable. But if you think about the set of all real number, what is the number after number 0? We don't know. You cannot say 0.01, right? Because I can always create another number closer to 0 by having like one more 0 adding to it. So we don't really know what is the next number after number 0 for the set of real number. So that's why this kind of set is uncountable. Does this make sense for everyone? Can someone confirm in the chat if you feel lost or does this make sense?
It makes sense.
Is that yes for lost? Oh, okay. How about everyone else? Do you follow what I say? Okay, thank you. Okay, that's pretty much about set cardinality. The next one I want to talk about is the concept of subset. We say that a set A is the subset of B if and only if every element in A is also in B. For example, you have the set 1, 2, 3 as the set A, and you have the set B is 1, 2, 3, 4. So you want to check whether A is a subset of B or not. You will go through each element of A. Okay, I go through this one. I have element 1. I will check it is element in B. And I see it here. So this element is in B. And then I move on to the next one. Is this element in B? Yes. Is this element in B? Yes. If you go through every single element in the set A and all of them are in the set B, then you say A is the subset of B. For this one, A is a subset of B. But let's say if you have a set C, like 2 and 5, you will go through each element in C. The first one I got is 2. It is an element of B. Yes, it is. So I move on to the next one. Is this element in B? No, it is not. 5 is not in B. Therefore, C is not subset of B. And another thing is an empty set. This one or this one, we call it an empty set. Is subset of every set. Okay. No matter what is your set, the empty set will always be the subset of that set. Now let's say you can check here, the empty set is subset of A, empty set is subset of B, empty set is subset of C. So empty set is subset of every set. If you want to know why, you can post on Piazza. I will put an explanation there. The next one is every set is the subset of itself. So you should see that A is a subset of itself. Why is that? Because you look through every element in A, you check whether this element is in A or not. And of course it is, right? And for every set, you would have that argument. Is C the subset of itself? So you can write C one more time and you compare it is element in C, it is element in C, and eventually you will reach, oh yes. So any set would be the subset of itself. Does this make sense? Okay, next one, I will briefly talk about the set operators. This is the intersection operator. And this will result in a set contains elements in both A and B. For example, your set A is 1 and 2, your set B is 2 and 4. Then the set A intersect B will result in some set that contains a common elements of A and B. And what are common elements of A and B? It is 2, right? Because 1 is in A, but it is not in B. 4 is in B, but is not in A. So the only common elements of A and B is 2. So A intersect B will give you a set of element 2. So this one is intersect. The next one is union. A union B would result in a set contains elements in A or B. So basically, what it means is you will take all the elements in A, and then you will take all the elements in B. However, a set is collection of distinct objects. So we see that we have repeat 2 here. So we will not write 2 again, and we will just write 4 down. Does this make sense? Thank you. Next one is the difference. It results in a set. Let's say you have A minus B, then it will result in a set of elements in A and not in B. Which means you will look at the set A and you will only input the element that is not in B. So you will check, is 1 in B? No, 1 is not in B, so I will write it down. Is 2 in B? Yes, 2 is in B, so I will not write it down because it has to be in A and not in B. So A minus B will result in a set of element 1. Any question about this one? Okay, if not, then I will give you time to think about question 1. Maybe 3 minutes, 3 or 4 minutes, and then I will take it up. If you have any question, you can type in the chat. For this kind of question, you can choose to take into account the order matter or not, as long as you stay consistent. Anyone got the answer for part 1? Can we do set builder notation? Of course, you can. The difference between part 1 and part 2 is part 1 is with replacement. So let's say you had 3 red balls and you have 2 yellow balls. For part 1, what it means is you will select the ball. For example, if you select this one, then you will write down that, okay, I got the red, but then you will put the ball back in. So in the second time that you draw, you can still be able to take this ball. So at the beginning of the second time that you draw, you still have 5 balls in total. So that is what they mean for part 1. And for part 2, what they mean is, for example, if you pick this ball out, you will write red, but then this ball will actually be out in the beginning of the second time that you draw. You will only have 4 balls left. So that is the difference between part 1 and part 2. You can choose to take into account the order or not. If you do, then there will be more outcome in your sample space. For example, in part 1, we have 3 red and 2 yellow, and we select 4 balls at random. Let's see, let AI represent color of the balls. I will just write out the student answer in the chat. AI is element of 1, 2, 3, and 4. And then you have set S is A1, A2, A3, A4. What's that? A1, A2, A3, A4. Is in red or yellow. Yeah, that sounds good to me. So what the students say is, yeah, this one. What the students say is the simple space is a set of tuple that contains 4 elements, and each of the elements can be red or yellow. For example, one outcome is, let's say A1 is red, A2 is red, A3 is red, and A4 is red. Or another way is A1, A2, and A3 is red, but A4 is yellow. So your simple space would contain such a tuple. It will contain all the possible combinations of this tuple, where each of them can take on red or yellow value. Does this make sense for everyone else? Of course, if you don't use a set builder notation, you are welcome to just list out all the elements, but it is quite long. How about the second part? If you take the ball out and you don't put it back in, then what would be your simple specs when you select 4 balls?
Well, we have like a limited amount of the red and yellow balls.
So if you think about it, after you remove the ball and you don't put it back in, for example, I take the red ball out, and then in the second draw, I also take the red ball out. And in the third draw, I also take the red ball out. Then it's not possible for my fourth ball to be red as well, right? My fourth ball definitely has to be a yellow ball. So that is one possible outcome. So I can have red, 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 and yellow. It just means when you select 4 balls and you have 3 of them are red, then the remaining one has to be yellow. And this yellow can be picked in the second draw, or in the third draw, or in the fourth draw, or in the first draw as well. For example, it can happen that you pick the yellow ball first, and then you pick other 3 red ball as well, like this. So another possible outcome is yellow, red, red, and red, or a red, yellow, red, and red, 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 yellow, and red. Okay. So those denote all possible outcome that contains 3 red ball. Wouldn't it be same as part 1? We just need to add more restriction in the set builder. Yes, you can add more restriction in the set builder. That's also correct. But you will have to be careful because you are taking in account the order of the ball. With this notation, it means that the first one I pick red, the second one I pick red, the third one I pick red, and the fourth one I pick yellow. This is different from the outcome where the first one I pick yellow and second, third, and fourth I pick red. They are different outcome with this notation. However, if you want that the order doesn't matter, what you can say is my outcome is that I have 3 red balls and 1 yellow ball. So that is also a reasonable outcome that doesn't take into account the order. Can we use word in our set builder? If 2 elements are yellow, then the rest are red. Yeah, you can use that. Okay, back to this one. So these 4 cover the case where you have 3 red and 1 yellow. And you will think about it, it is not possible to have 0 yellow ball, right? Because having 0 yellow ball means that you have 4 red, and you just don't have enough red balls for that. And then you will think about, can I have 2 yellow balls? And yes, you can, but you cannot have more than 2 yellow balls. So when you have 2 yellow balls, it means you will have 2 red balls because you pick out 4 balls in total. So one of the outcomes that you can have is the first and second pick, you pick red. The third and fourth pick, you pick yellow. Or you can pick yellow first in the first 2, and then pick red in the last 2 pick. Or you might be able to have something like this, or like this, or something like this. But we put the balls back in the bin so they can be used again. This one, the second one, they don't put the ball back. The first one, we did put the ball back. That is selection with replacement. But for the second one, it is without replacement, so we don't put the ball back in. So this answer is for the first one, and this answer is for the second one. Does this make sense? Can you read out the set builder answer for number 2? Yes. So you can have this, A1, A2, A3, A4. Let's see. So you will have that. Three of AIs. All right. Then the remaining is yellow. And if 2 of AI are yellow, then the remaining is red. So we don't allow the case where we have 4 red, and we don't allow the case where we have like more than 2 yellow. But I think for part 2, this kind of answer, I think is easier to come up with. For part 1, this one is more convenient. Any question about this one? Okay, if not, then I will leave you time to think about question 2. Maybe 3 minutes, and then I will pick it up. If you have any question relating to question 1 or question 2, you can type in the chat. Did anyone got answer for part 1? Here you have 4 switch. And for each of them, they can be on or off. We could have a total of 4 elements that show each switch. Yeah, that's totally correct. Yeah, that makes sense. So I can have like, let's say A1, A2, A3, and A4. And each of the AI represents the state of the ith switch. And I can have that AI is either on or off. And I is 1, 2, 3, and 4. Like this. Remember, when you write a simple space, make sure to use the curly bracket to indicate that a simple space is a set. That is very important. The next one, we want to identify each of the following events as a subset of the simple space. The first one is A1, where we have water flow from point D to point E. In order to have water flow from D to E, what does that mean in terms of the on and off for the switch? I and 2 are on. Yes, that's correct. In order for water to flow from here to here, then these 2 need to be on, right? So you can have like on, and then A3 and A4. And then does the value of A3 and A4 matter? Do they have to be both off, or they can be on or off? Doesn't matter. Yeah, I see some students trying to list this out. That's also a correct way to do. But here I will go with like A3 and A4 can be either on or off, and it doesn't matter. Another way you can write is just list it out like on, off, or like on, and then off, on, off, something like that. That's also correct. You will have 4 elements. Next one, there is water flow from B to C. So we don't need the let statement. No, we are not that formal in the course. Don't worry too much. We want water flow from B to C. What does that mean? A3 or A4 are on, and the other don't matter. That's correct. So I can have like A1, A2, I don't care, but I need A3 to be on, and then I will not care about A4. And then I will union with the set where A4 is on. Does this make sense? So it can be this case where A3 is on, or it can be this case, or it can be the case that both of them are on. And it happened when A4 here takes on the value on. Does this make sense to everyone? Will we also write this as one set? Yes, you can write that too. Yep. And then A3, we want a water flow from A to F. In order to flow from A to F, it means either they go this way, so flow from D to E, or they flow from B to C, right? Yes, exactly. It's union of A1 and A2. And if you write it down, you can just literally copy paste this one. And then you union with the part I write for A2. Like this. Is there any other question about this one? I assume that no. Let's forget this. Okay. I will give you maybe 2 or 3 minutes to do problem 3. I think it's pretty straightforward. If you have any question, you can always type in the chat. Anyone got the answer for part 1? A1, A2, A1, A2, yes. So your simple specs will just be A1 and A2, where they can take on any value from 1 to 6. Is this finite, infinitely countable, or uncountable? For part 1, yes, it's finite. And indeed, this set would have 36 elements. The next one, random selection of natural number less than 100. I see some student give me this set, and it looks correct. And it is finite because the number of objects in the set is finite. How about 3? Life duration of electronic appliance. Yes, it can be like any number from 0 to infinity, right? Then it would be infinitely uncountable. How about the 4th one? Yes. So we have negative infinity to infinity, or you can think of this as the set of all real number. And this one is one of the infinitely uncountable set. Any question about this problem? Okay, if not, then I will let you time to think about question 4, maybe 2 or 3 minutes. Can we say uncountable, or we say, yeah, you can say uncountable. Did anyone got the answer for part 1? How do we represent that all 3 events occur? Yes, A intersect B intersect C, which means that I want A to occur, and B to occur, and C to occur. How about the second one? At least one of them occurs. Yes. A occur, or B occur, or C occur. How about 3? A and B prime, yes. So I want A occur, and I don't want B to occur. Or you can use, I want A to occur, but just the part that does not have B. How about the fourth one? Yes, so we have A and C to occur, and I want B to not occur. How about the fifth one? Yeah, I saw it. You got it mixed up between B and C. What did you get for the fifth one? So you want at least one of 3 events to occur, but not C. So definitely you wouldn't want to see something with C in it, unless it is C complement, right? Yes, so you would have A or B and C complement. Or if you cannot be redundant like this, what you can do is at least one of the three events occur. So you take the answer from part 2, which should give you A union B union C, and C does not occur, so you intersect with C complement. That is also correct. But then this one can be reduced to just this one. If we use a B in one expression, can we also use the intersect symbol in that same expression? Yes. So the AB means that A intersects B. How about the last one? What did we get? Can we come by the format? Yes, that doesn't matter as long as you write down the correct answer. The last one, exactly 2 events out of 3 occur. And I see some students say AB, or I will assume you mean or is the union. It is correct. Does AB guarantee you that exactly 2 events occur, or it guarantee that at least 2 events occur? Because if you just know that A occur and B occur, and you don't know any information about C, then it's possible for C to occur as well, right? Yes, that new one is correct. So you need to put that restriction that if A and B occur, then I don't want C to occur. So I will need to add C complement. Similarly here, if A and C both occur, then B must not occur. If B and C occur, then A must not occur. So this would be the correct answer. Any question about today's tutorial? Could you please match the question number with the textbook next time? Yes, I will try to. The thing is, all the questions today and all the questions on Wednesday, I took it from textbook, but in the future, I might just grab question from somewhere else as well. So I didn't think about putting textbook question, but I can definitely add that if I take any question from the textbook. If there is no question, is the end of our tutorial today, and I will see you on Wednesday. I would suggest you to look at the tutorial on Wednesday first to give you more time to work on it. Have a nice day, everyone.